The overall aim of the GlobCurrent, as is indicated by the title, is to be able to provide quantitative information about the surface current around the Earth, in terms of both at the global level but also at regional and local levels.
GlobCurrent, in one sense, is a very challenging project because what we really aim at is providing the best ocean surface currents we can for people who are actually working at sea.
The European Space Agency is funding the GlobCurrent project out of the data user element, which is designed to link the users together with the satellite data. What we do in this program is try to make sure that we understand exactly what users need, bring together a team of specialists and scientists and engineers to work together with users to provide the best products to answer their questions.
Well, the challenge is that there are a number of different technologies that can provide information on the ocean currents, and the idea is to combine the information we're getting from different satellites.
We need better information because currents are the engines in the ocean. It moves elements around: heat, energy, pollutant material, toxic and atomic nuclear material, and can also have very unpleasant and surprising effects on the fishery, the marine ecosystem.
We're measuring from space sea surface temperatures, which give you a good idea of the overall mesoscale and sub-mesoscale structures. We are measuring ocean colour parameters, which again, while they're non-conservative, also give you a good idea of a different aspect of the sub-mesoscale and mesoscale parameters. We're measuring sea surface height from altimetry, from which we can deduce ocean flows. We're measuring the Earth's gravitational field, from which we can derive a geoid, and together with altimetry, that gives us a measure of absolute currents. We can measure using synthetic aperture radars and scatterometers that surface ocean roughness, and from that we can derive estimates of the wind field, and cutting-edge techniques today give us an estimate of the ocean surface current from the synthetic aperture radar. So bringing all that together is the challenge.
Now we go after the combination of several satellite sensor systems. So from that perspective we can give a much wider range of information about the surface current than what is possible to do only from one sensor at a time. This combination, we believe, is what makes the GlobCurrent project now unique and timely.
The GlobCurrent products are of particular interest to the science community, especially those involved in understanding the climate. But there are a lot of users in industry who are interested in our products, whether it be the large marine vessels that want to minimise their traffic time, the leisure yachts, people in search and rescue wanting to know what happens in a man overboard situation. We've also had a degree of interest from the aquaculture industry about concern about harmful algal blooms being transported past their farms. And of course the oil industry is another bigger user.
We think in the oil and gas industry that GlobCurrent has a potential to offer us significant insights into the ocean currents at the sea surface. As we move into deeper waters, we have a lot of infrastructure at the surface as well as through the water column. So it's increasingly important to understand what the current is doing at the surface for things like operations, for oil spill response and activities such as those. It's both the safety aspects of operations, it's also associated with the design of new infrastructure, so we understand what the forces will be on our surface features, and also in the case of an emergency such as an oil spill or perhaps an incident with a ditching of a helicopter, understanding where the oil, or in the case of a helicopter, where the debris may drift to.
GlobCurrent, in the end, is already attached to a very large user community. What we hope is that these people take full benefit from a demonstration service that gives them the best estimates of ocean surface current from space, and from that we can understand their evolving needs as they learn how to use that data and tell us what's needed for not just a new set of ocean surface current data, but possibly even the next generation of Earth observation satellites to address their needs.